Hello, I'm Amanda, and today I'm going to talk about how bodyguard ants affect the pollination of their host plants. But first, let's think about mutualistic interactions. I bet when you think about mutualistic interactions, you think about the benefits involved in these interactions. For example, in the interaction between bee and flowers, bees receive nutrition from the plant, while flowers receive pollen transportation. But mutualistic interactions also involve costs for mutualistic partners. For example, bees need to search for flowers, and usually flowers lose part of their pollen because bees consume their pollen. So the outcome of mutualistic interactions depends on both benefits and costs of these interactions. And here I'm going to focus on protection mutualisms. In these mutualisms, plants offer nutrition for partner ants, usually in extrafloral nectaries, EFN. And while patrolling the plants, ants can repel or eat herbivores, reducing herbivory damage. But also while patrolling plants, ants can repel or consume pollinators. In this case, ants should impose an ecological cost to their house plants. And here we have a video showing this. So here we have some ants, and we can see that ants are repelling the bee. So ants have a positive effect for plants because they can reduce herbivory damage, but they can also affect pollination. So what's the effect of ants for their host plants? And here we think that the effect of ants depends on the aggressiveness of ants. Because subordinate ants don't recruit a lot of ants, they are less aggressive. So in this case, pollinators can pollinate the plant even in the presence of subordinate ants because they are not aggressive. But when you think about dominant ants, they are super aggressive, they recruit a lot of ants, so these ants should impose a higher cost for plants. But also, we can think about EFN position because EFN can be only on vegetative structure, but they can also be on reproductive structure. So when EFN is also on reproductive structure, it's expected ants patrol more often the flowers than when EFN is only on vegetative structure. So here, for this presentation, we have three hypotheses. The first one is that ants have a negative effect on the visitation pattern and on reproductive success of their host plants. The second one is that aggressive ants should impose a cost to their host plants. And finally, we expect a more negative effect when EFN is on reproductive structure and on vegetative structure. To evaluate this hypothesis, I just sit here in my computer and search for some articles on Web of Science and Scopus databases in order to build my databases. So basically, we conduct a meta-analysis, and as a main criteria to include a study, we consider studies in which they evaluate visitation patterns, such as duration of visits or frequency of visits, and reproductive success, like number of seeds or number of fruits in plants with and plants without ants. And in order to calculate the effect size of this meta-analysis, we consider plants with ants less plants without ants and divided by pooled standard deviation, which means Hedges G. So what did we expect? So here we have Hedges G, and the negative Hedges G and the positive Hedges G. And we expect a negative Hedges G, which means that ants impose a cost to their plants, to their host plants. But when we consider visitation pattern and reproductive success of the plants, we also expect a negative effect of ants. But when considering ant aggressiveness, and especially subordinate ants, we don't expect an effect of subordinate ants because they are less aggressive, they don't recruit a lot of ants, but we expect a negative effect of dominant ants. Finally, when we think about EFN position, we expect a more negative effect when EFN is on reproductive and vegetative structure than only when EFN is on vegetative structure. So, okay, what we found? We found that ants have no effect on plants, on their host plants. But when we think about visitation and plant fitness, we can see that plants, in fact, affect visitation. So we have a negative mean, Rede, and they don't affect plant fitness. So they affect visitation, but not plant fitness. When we think about subordinate ants and dominant ants, we do not find an effect on both ants, subordinate or dominant ants. And finally, when think about the EFN position, we did not find an effect of ends according to EFN location. So, okay, what does it mean? So, although ants have a negative effect on pollinator visits, they do not affect plant reproductive success. And also, the negative effect of ants is not enhanced by ant aggressiveness or EFN location. And why we think we had this result? Maybe this happened because flowers just need few visits to be pollinated. So here we have a bee. She is pollinating the flower. And visiting other flower. They are lighting the pollen there, going away. So what's the implications of our results? So we saw that bodyguard ants do affect visitation, and this can impose an ecological cost to pollinators, which means reducing the duration of visits of pollinators, or by making the pollinators traveling more between flowers because they stay less on a flower and they need to get their resource, their food. Another implication is that bodyguard ants do not affect reproductive success of their host plants, so they do not impose an ecological cost to their host plants. So the message I want you to keep from this presentation is that bodyguard ants affect pollinators, but not reproductive success of their host plants. And finally, protection mutualism has a positive effect for host plants, even in situations in which there is a conflict between ants and pollinators. I want to thank you for watching this. If you have any doubts, don't hesitate to contact me. So here I have my mail and my Twitter. Thank you.